All right, type 7, just a bunch of miscellaneous type of questions. This first free response question is 2014 BC. This is a volume question. This type of question is not on the 2020 AB exam. So in part A, you were to find the area of R. The area of region R here is going to be the top curve minus the bottom curve, where the top curve is this x e to the x squared, and our bottom curve is our linear function negative 2x. And integrating this is number 5, so there is no calculator. I'm going to use u substitution to integrate the x e to the x squared, and then integrate 2x is just x squared from 0 to 1, and we have our answer here, 1/2 e plus 1/2. All right, part B is to write but do not evaluate the integral expression for the volume of the solid that is generated when R is rotated about the line y equals negative 2. Okay, so I've just drawn one washer, so we know there's a hole, and so our integral expression is going to be pi from a to b of big R squared minus little r squared. Big R is the function x e to the x squared plus 2, because we're revolving around this line y equals negative 2. And then our small r is going to be negative 2x plus 2. And so we're going to go pi from 0 to 1 of our big R squared minus our little r squared dx. Part C is to write up an expression for the perimeter of R. So for the two curves, that's going to be the arc length, and the arc length formula is 1 plus y prime. And down here you'll see a little chicken scratch here. If y equals x e to the x squared, it's going to be the first times the second plus the second times the first. So this first expression is going to give us this length right here. The second expression from 0 to 1 of the square root of 1 plus negative 2 squared is the length of this line right here. And then e is this height from 0 to my exponential function, and then 2 is this bottom length right there. All right, 2012 AB question number 4. This is a non-calculator question. You are given the function f of x as the square root of 25 minus x squared, and then I just wrote it as a power 25 minus x squared to the 1/2 power. I took the derivative of the power rule, so it's 1/2 25 minus x squared to the negative 1/2, and then don't forget the chain rule, times it to the inside part, which is negative 2x. And my domain there is from negative 5 to positive 5. It didn't ask for that, but just be careful because the denominator is 25 minus x squared, so you cannot include negative 5 and positive 5. Part B is to write an equation of a tangent line at x equals negative 3. I found the value of f of negative 3, so f of negative 3 is positive 4. We knew what the slope was from part A, so f prime of negative 3, when I plug those negative 3 into the equation I got in part A, I got 3/4. And so here we have y minus 4 equals 3/4 x plus 3. Is G continuous when x equals negative 3? So my definition of continuity is right here, and so I'm going to check to make sure that g of negative 3 actually is defined. G of negative 3 is f of negative 3, which is positive 4. The limit as I come from the left is still positive 4 of g of x. The limit as I come from the right of g of x is going to be that negative 3 plus 7, and that's also 4. So we know that the limit exists. Since the right-hand limit equals the left-hand limit, they both equal 4, and therefore we know it's continuous. Part D is to actually integrate from 0 to 5 of x times the square root of 25 minus x squared using u substitution. And then I also use change of my limits of integration. U of 0 is 25 minus 0 squared, and u of 5 is 25 minus 5 squared. So now I'm going from 25 to 0, and if I change my limits of integration, I don't need to substitute my u back in. I can stick with just my value of u, and my final answer is 125 over 3. All right, 2011 AB number 6. You were to show that f is continuous at x equals 0. Again, remember the parts of being continuous is that we have to show that f of 0 exists here. And so I'm going to plug in 0 and I get 1. I also have to show that our limit of f of x as x approaches 0 from both the right and the left have to be equal to the same thing. So plugging those in, I get 1 from the left and I get also 1 from the right. And therefore the limit exists, and since the limit also equals a value f of 0, then we know that we have continuity when x equals 0. Part B is to express f prime as a piecewise defined function except for when x is equal to 0. And so f prime, I just took the derivative of those two pieces. And then the second part of that was to find the value of x for which f prime equals -3. Okay, so this first piece here, when x is less than 0, is equal to -2 cosine x. Well, since we know that cosine x lies between 1 and -1, -2 times that has to lie between -2 and 2. So that's never going to be a value of -3. So we're going to set -3 equal to that second piece of this piecewise function, and then using natural logs, and we solve for x there. Part C is asking you to find the average value of f on the interval, the closed interval from -1 to 1. So this is a piecewise function. So the average value is 1 over b minus a. Okay, that stays the same. That little piece stays the same, which is going to give us 1/2. But then this first piece is from 0 to 1, and the second piece is from -1 to 0. All right, and so I integrate each of those pieces. I use FTC number 1, f of b minus f of a. Be very careful, we don't have a calculator. You can clean up the inside or you can just leave it like this. All right, 2014 AP free response BC number 4. However, AB can do all of these parts. Okay, this is probably a shared question in 2014. Here we go. So finding the average acceleration is just delta v over delta t. And from 2 to 8, I just use these values from the table and get -220 over 6 meters per minute squared. Part B asks, does the data in the table support the conclusion that train A's velocity is -100 at some point during the interval from 5 to 8? Well, we know that our velocity of particle A or train A is differentiable, which also means it's continuous. And therefore, by the intermediate value theorem, since we know the velocity of A at 5 is 40 and the velocity of A at 8 is -120, then there must exist at least one time t between 5 and 8 such that the velocity of A of t is equal to -100. You also know that because -120 is less than -100, which is less than 40, or you can say v of 8 is less than -100, which is less than v of 5. Part C, it's asking for the train's position at time t equals 12. Well, we know the integration from 2 to 12 of the velocity is the same thing as x of 12 minus x of 2, the difference in the position. If we slide that x of 2 over to the opposite side of the equation, we know that x of 2 plus the area underneath the velocity curve from 2 to 12 is equal to x of 12. It says using trapezoidal sum with 3 subintervals. And so here's my first trapezoid here. This is my last trapezoid. My middle trapezoid is a little bit interesting looking because we have a height of 40 at one point and a height of -120. But just using our formula here in the middle, we can still do that. You can leave it in that unsimplified form. If you simplify it all the way down, you're going to get -150. Part D, a little related rates problem. We have now a right triangle where we're 300 on the x or the horizontal, 400 on the y or the vertical. I can use my Pythagorean theorem. I take the derivative with respect to time. We know the position of x. We know the position of y. I can find the position of my second train B by taking, or find the velocity, of the second train B. So here, this is dy dt here, and I use that from the velocity function that's given in part D. plugging that in and dividing by 500. Again, you can leave it in its unsimplified form. If you simplify it, we get positive 160 meters per minute. All right, the next free response question is 2015 BC, number 5. However, AB calculus students can do parts A, B, and C. Part A is giving a rational function when k is equal to 3 and taking the derivative. All right, and so we just showed that, and they wanted specifically to find the line tangent at the point where the x-coordinate is equal to 4. So we have the derivative. I put in 4 for x, wherever there was an x here, and all these different places, found the slope. All right. We also find f of 4 by plugging in 4 into the original given equation when k is 3. And I find that value is 1/4. And so we get y minus 1/4 equals negative 5 over 16 x minus 4. Part B, we're letting k be 4, and we were determining whether f has a minimum, a maximum, or neither at x equals 2. So again, finding the derivative and then plugging into the derivative, we find that that's equal to 0, which tells us that x equals 2 is a critical number and it's a candidate for a relative extrema. Using the number line just to give us an idea of what's going on, I chose a value less than 2, which is 0, plugged it into the first derivative, chose a value greater than 2, I chose 10, plugged it into the first derivative. I found that we're positive to the left of 2 and negative to the right of 2. And because of that, we need to write this sentence: since f prime changes sign from positive to negative when x equals 2, f of x has a relative max when x equals 2. Part C, we're asked to find the value of k for which f has a critical point at x equals negative 5. Again, we know what the derivative is. I took the derivative there. Here, we know that this is going to be a critical point when the numerator is 0, so I set the numerator to 0. I plugged in negative 5 for x and solved for k is equal to negative 10. Part D is a BC only question. It's asking you to integrate 1 over the x squared minus 6x. I can factor that x squared minus 6x and then use decomposition with partial fractions here in the red to solve for a and b. We get a is negative 1/6 and b is positive 1/6. I'm going to pull that constant 1/6 out, and I'm going to integrate each of those pieces. We get negative the natural log of x, absolute value of x, plus the natural log of the absolute value of x minus 6. You can leave it like that, but we're going to simplify that right there to give you 1/6 natural log of the absolute value of x minus 6 divided by x plus c. All right, multiple choice questions here. In this first question, you're given a differential equation. I just isolated dy dx here in this second line. It's asking you to find the second derivative specifically at the point 3, 0. So the second derivative is of a quotient. So I use the quotient rule here. I know dy dx, boxed in the red, okay, is equal to 2 at the point 3, 0. So I'm going to put 2 in wherever there's a dy dx. I'm going to put a 3 everywhere there's an x and a 0 everywhere there's a y. Simplify that algebraically. I get negative 10 over 3, or choice A. All right, and number 77, we have a closed interval from 2 to 4. We know f of 2 is 10, f of 4 is 20, so I do a little picture right here. And they're asking us which of the following is guaranteed by the intermediate value theorem. If this is a continuous function on a closed interval, we know that if I go from 10 to 20, I've got to go be able to reach all the values in between 10 and 20. So choice A is that f of x equals 13 has at least one solution in the open interval, which means if I graph a line at y equals 13, it's got to cross at least once. So that's choice A. Choice B is a related rates problem. It has a man walking away from a headlamp or a lamppost, and they know the man is 6 feet tall, the headlamp or the lamppost is 15. I'm going to let x be the distance from the man to the tip of the shadow, and y be the distance from the lamppost to the man. And so I set up a ratio of similar triangles. 6 over 15 is x over x plus y. Cross multiply Clean it up, so 6y equals 9x. Differentiate each side with respect to t. I know dy dt, that's given in the stem of the problem. I plug that in for for dy dt, which is 4, so I get 6 times 4 equals 9 times dx dt, and that simplifies to 8/3, or choice B. All right, number 4, multiple choice, is not an A-B question. It is a BC question only. It's asking for the length of the curve, which is the same as arc length. If y equals ln of x, then its derivative is 1 over x. Here's the equation for arc length. And then, so I'm going to just plug in for my given function, and that gives us choice A. Choice 7 is both A, B, and BC. You're given arc sine of x equals ln of y, and you're looking for dy dx of that expression. So a little chicken scratch over here. If I know inverse sine or arc sine of x equals y, let me rewrite that in the second line as y equals sine y. X equals sine y. I'm going to differentiate both sides with respect to x, so I get 1 equals cosine y dy dx, and then I'm going to solve for dy dx. Now, we get 1 over cosine y, but up here, x equals sine y, so I can draw my little triangle, and then 1 over cosine y would be 1 over adjacent over hypotenuse. And so the derivative, the derivative of arc sine is 1 divided by the square root of 1 minus x squared. So that helps us in this first line over here. And then I'm just going to solve for dy dx, and that's choice A. Number 11, f of x is the square root of the absolute value of x minus 2. Knowing that the square root function looks like a v with its vertex at the point 2, 0, the square root is just going to sort of soften those edges. Instead of being linear, it's going to look a little more curved. But it's going to have a sharp point there at 2, 0. We know it's never negative, and therefore we know this function is going to be continuous here, but not differentiable. And that would be choice A. In number 12, we're given 2 points, -1, -1, and the point 1, -5. We're also given dy dx is defined as x squared plus y. Plugging in 1, -1, dy dx becomes equal to 0, which means it's a critical number. Then finding its second derivative and plugging in the point -1, -1, we get the second derivative is going to be less than 0, which tells us we're concave down and we have a relative max. If you're going to double check at the point 1, -5, we find out that that is not a critical number because the derivative, which is given in the stem of the problem, is not equal to 0. All right, 77. We have 2 functions, e dx and x to the 4th. The question asks, on what intervals is the rate of change of f greater than the rate of change of g? So I'm going to take the derivative of both of them, and I graph it here. E dx, or f prime e dx, is green, and then g prime, which is 4x cubed, is the black curve. Now, they intersect in 2 points. The unfortunate thing is to find the second point right here, you actually have to go to almost 2,000, or a height of almost 2,000. But the green graph, e dx, the derivative of f, is above g prime from -infinity to 0.831 and 7.384 to infinity. Part B is asking for the average value of y equals the square root of cosine x. Here's our average value formula. Using our calculator here, I have 1 over b minus a, or pi over 2 minus 0, from 0 to pi over 2 of the square root of cosine x dx. Using the calculator to find the area underneath the curve of the square root of cosine x from 0 to pi over 2, I get 1.198. Multiplying it by that constant 2 over pi, we get choice C.